Okay, so in today's notes, what we're going to be doing is we're going to be talking about testing the correlation. So real quick, just a little bit of vocab. We've got true correlation and observed correlation. So think of these like your ability and your performance. So true correlation is someone's correlation between two variables, like the ability of an athlete, and it exists only in theory. So we can never really truly know what someone's correlation is, but their observed correlation is a correlation between two variables, like the performance of an athlete and is based on a limited amount of data, such as one season. So in this example right here, the first one we're going to be talking about is regular season win percentage and spring win percentage. So in almost every sport, teams play exhibition games before the regular season begins. While these games don't count in the standings, most people think that a team's performance in the exhibition games is a good predictor of how well the team will do in the regular season. Other people, especially fans of teams that aren't doing well in the exhibition games, suggest the performances in exhibition games tell us nothing about what the future holds. So the scatter plot below shows the 2009 winning percentages, or WP, for 30 MLB teams during spring training and during the regular season. And so we've got a dot for each of the 30 teams. And so we got their spring win percentage as the explanatory, and then regular season win percentage as the response. And so first thing it says is that the correlation for this data is 0.45, positive 0.45. So it says, based on the scatter plot and correlation, there seems to be a moderate positive linear association between spring training and regular season. So a scatter plot of data should look completely scattered and the correlation should be zero except for random chance. However, if by random chance a majority of the team that played well in the spring also happen to do well in the regular season, and by chance, the majority of the teams that played poorly in the spring also happen to play poorly in the regular season, the observed correlation would be positive, even though the true correlation is zero. So what we're going to do is we're going to test to see if there actually is a correlation between regular season and spring win percentages. And so to see if the observed data provides convincing evidence that there really is a positive association, um, we will test the following hypotheses. So we've got a null hypothesis and a true and an alternative hypothesis, and these are both just talking about true correlation. Okay, just true correlation. And so remember, usually our null hypothesis says something along the lines of two things being the same. In this example, we're going to be talking about the true correlations being zero, which is essentially saying there's no difference between them. So we can say true correlation between winning percentage in spring and win percentage in the regular season is zero. That's our null hypothesis. And then our alternative is the true correlation between winning percentage in spring and regular season is positive. So there's a difference, a positive difference. Um, Now it says describe how to simulate the distribution, assuming that the correlation is zero. And we're going to do that using note cards. So it says using 30 note cards because we've got 30 teams. We're going to use 30 note cards. Write one of the regular season win percentages on each card. Then shuffle the cards and randomly pair each of them with one of the spring training win percentages. And we're going to calculate the correlation and record and repeat. And now it says we're going to do 5 simulations or do the simulation 5 times a piece and record the data on a dot plot. We don't have more, we're not able to do that together. So I just have an example here. So let's say, for example, we simulated this season, this regular season and spring season 97 times. Okay. And the reason there's 97 is because in previous years we had 97 kids or 97 trials of it. But let's say 97. Out of those 97, what we did was we counted the number of seasons where we had a correlation of at least 0.45. So if our correlation was 0.45 or more, we counted it. And after going through all 97 of them, we only had 4 out of the 97 where there was a correlation of at least 0.45. So our p-value in this case was 4%. So this right here, this assuming that the correlation is zero, this is us interpreting the p-value. So assuming that the correlation is zero, there's about a 4% chance of getting a value of r greater than or equal to 0.45 by random chance. and then this is a conclusion. So since our p-value is 4%, we can say we reject the null hypothesis, and we do have convincing evidence of a positive association between an MLB team's winning percentage in spring training and winning percentage in the regular season. And so that's how we would do it by hand. Now, if we were wanting to do it by computer, this is how we're going to do it. So these notes are actually in the folder here. So if you want to see this, you're welcome to do that, or you could just pause the video here and look at it. But I'm going to show y'all how to make a scatter plot and your dot plot for the simulation, all in one go. And we're going to be using the Staplet website. So if I go to Staplet right here, okay, so I go to staplet.com, this website, and this is where it brings me. This is the same website that we used for our investigations. But if I scroll all the way down and then I click on applets for stat reasoning and sports, this is chapter 10, so we're going to click on correlation and regression, see where it says chapter 10. And then right here, it brings me to this app. And so what I want to do is I want to put in my explanatory variables in list 1 and my response variables in list 2. And I also want to label these axes. And so just as an example, I've got, where is it? Right here. So this was day 1 notes. So day 1, displaying relationships with scatter plots. So I'm going to be using the top 10 money winners for the LGPA Tour in 2009. And so I've got average driving distance and driving accuracy. And so I'm going to use average driving distance as my explanatory and my driving accuracy as response. And so all I'm going to do is I'm going to be putting these uh, in my explanatory and my response lists. So I've already got that on this page right here. I just went ahead and put those in. Here, let me show you. Let me do this. So I've got average driving distance right here. See where I labeled it average driving distance. And then my driving accuracy values, these values right here. And then I've also got it labeled driving accuracy. And so what I want to do is if I click calculate observed statistics, it will make a dot plot for me. Or excuse me, a scatter plot. It'll make a scatter plot for me, and it'll also tell me the correlation, okay, the R value. So if I scroll down just a little bit, it'll ask me to simulate. This is where we simulate. This is a representation of one season, one set of data. If I want to simulate that data over and over again, I go down here and click simulate 100, keep it as correlations, and then click add more trials. And then it creates a dot plot for me, okay? And so that is how I'm going to create my dot plot, okay?